Namaste student. Today we are going to discuss about the similarities between electric field, that is from Coulomb's law, and the magnetic field from Biot-Savart law. Before that, in our last class we discussed Biot-Savart law. Biot-Savart law, consider any one of the conductor, the electric current I which are passing through it. We have to choose a small element of length dl. Through this length dl, when current I which are passing through it, the magnetic field produced is what? A small amount of dB. The magnetic field produced due to the current I which are passing through the length dl is dB is proportional to current, proportional to current element length dl, proportional to sine of the angle between this dl and the position vector r, inversely proportional square of the distance. Db is equal to k into ideal sin theta by r squared. K is called proportionality constant. K is equal to mu naught by 4 pi. And the previous case, the previous heading is what? Aerostat experiment. When current which are passing through the conductor, magnetic field is produced. The producing magnetic field should be acting perpendicular direction of electric current. When you want to find out the direction, we may use right hand thumb rule or Maxwell corkscrew rule. Corkscrew rule. That is in our last class portion. In Biot-Savart law is only one of the very important case, and also in Biot-Savart law, the magnetic field produced due to current which are passing through the conductor, its direction should be mutually perpendicular to the current element dl and the position vector r. Current element like this, position vector like this. So the magnetic field produced perpendicular to both current element as well as the position vector. If the direction of the current from bottom to top means, top to bottom means the position vector, that is magnetic field which are acting what is coming out dot. This continuation only the similarities between electric field and the magnetic field. The same chapter, third chapter, magnetism, the difference and the comparison we have to discuss. The electric field mean space around the charge wherever the electric lines of force exist. Electric field E is equal to F by Q naught, because when the test charge is placed, we can get what? Electric field is measured. Like that, magnetic field means force experience or the around the surface of the magnet wherever the magnetic lines of force exist. When you want to measure, B is equal to F divided by unit north pole, M, unit north pole placed at the point. This is also one of the similarities. Electric field E is equal to F by Q naught, magnetic field B is equal to F by, that is B is equal to what? F by M. Here the similarities between electric field and magnetic field from Coulomb's law and Biot-Savart law. What is Coulomb's law? Coulomb's law means no doubt F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 by R squared. Force is the force of attraction or repulsion between any two charge is directly proportional to product of magnitude of the charges and inversely proportional to square of the distance between these two charges. That is Coulomb's law. Biot-Savart law means just like I told, dB is equal to mu naught by 4 pi ideal sin theta by r squared. What is the similarities between these two laws? What is the similarities between these two cases? That only is here we have to discuss. In this case, the first point, the current element ideal produces a magnetic field, whereas the electric charge or the point charges only produce the electric field. Current element means what? Just like a conductor, when conduct through the conductor, electric current I which are passing through it in a small element of length dl, magnetic field is produced here, the magnetic field dB in this point P. So magnetic field is produced due to the current element, and as magnetic electric field is produced due to what? Point charges. Point charges mean if the charge is positive mean electric lines of force which are coming out like this. If the charge is negative means what? Electric lines of force which are moved toward the charge radially inwards. In positive charge, the electric lines of force which are coming out radially outwards. Right, first similarity. Second, Both Biot-Savart law as well as Coulomb's law, both of them obey inverse square law. Inverse square means what? Force is inversely proportional to distance squared, 1 by 4 pi epsilon naught, 9 into 10 power 9 constant. Q1, Q2, 1.6 into 10 power minus 19 coulomb, 1.6 into 10 power minus 19 coulomb. Even this overall the factor is constant. So this is constant means we can write what? Force is inversely proportional to square of the distance. Obey inverse square. Inverse square. Inverse means what? A is the matrix 1 by A. That is called what? A inverse 1 by A. That means what? A inverse. That is in the inverse. Denominator square is there. Inverse square law. What about here? Even here also B is equal to, that is here dB not B, because dl mu naught by 4 pi ideal sin theta by r squared. Mu naught by 4 pi is constant. Mu naught constant 4 pi into 10 power minus 7 Henry per meter. I constant, dl constant, even sin theta, angle also what? Constant. So dB is inversely proportional to square of the distance. Means what? Both Coulomb's law as well as Biot-Savart law, both of them obey inverse square law. Third point, electric field is created by a point charge, is radial. It's very important point. That only I told. Radially, if the charge is positive, electric lines of force which are coming out from the charge is radially outward, radially perpendicular. Radius means what? Radius is line drawn from the center of a circle perpendicular to the tangent, that is called radius. Even tangent also definition, we know that in our lower class, tangent is a line touches on a single point of a circumference of circle, that line should be acting perpendicular to the radius. So radially outward if the charge is positive, suppose if the charge is negative mean radially inward electric field. But the magnetic field, that is B vector, the magnetic field is created by a current element dl is perpendicular, is very very important, perpendicular to both dl as well as the position vector or cap. So this is the conductor. The conductor is what? Infinite length xy, infinite length whatever may be. Within the length we have to choose the small element of length dl. In Biot-Savart law we chose when current I which are passing through this wire, due to the length dl, the magnetic field in this point we have to find that magnetic field is dB vector. When you want to find the direction, we may use right hand thumb rule. We have keep it our right hand like this. Thumb finger will give the direction of the magnetic field, electric current. Thumb finger, the remaining finger will give the direction of magnetic field. So magnetic field which are acting what? Perpendicular, inwards. So inwards will indicate the symbol star. Outwards means dot, we know that. So the magnetic field in this point should be acting, just now I told this is the direction of the electric current, this is the position vector, mutually perpendicular to both electric as that is what? Both the dl as well as what? Position vector, that only is given perpendicular to both the dl vector. So this is the conductor mean conductor. So dl vector here we have to take this is the dl as well as what? This is the position vector r cap. In this point only we have to find this what? Magnetic field. This magnetic field in this point, this is the direction of the current, thumb finger, right hand thumb rule. Magnetic field will give the direction of what? The remaining forefinger, the forefinger which are acting perpendicular to the board inward, the current which are passing through bottom to top. Suppose top to bottom means it should be coming out here. So at that time the magnetic lines of force in clockwise direction, now in anti-clockwise. Anyway, magnetic field in this point P, should be perpendicular to dl as well as the position vector r cap. So this is the similarities between what? Electric field and magnetic field, that is from that is Coulomb's law and Biot-Savart law. This is the similarities, right? Now like similarities, what are the difference between electric field, that is from Coulomb's law, and magnetic field from Biot-Savart law? Even textbook the table is given, electric field, magnetic field, we have to separate it. But the first difference between these two, electric field produced from a charge. Charge is a scalar quantity. Electric charge is a scalar quantity. So that produced by a scalar source, that is an electric charge. but the magnetic field produced by a vector. What is the reason? Electric current which are passing through the current element. Current element means just like a conductor. Within the conductor, we have to choose a small length dl and current which are passing through. Current which are passing through either bottom to top or top to bottom. At the time of current which are passing through the conductor, direction is there as well as magnitude. Therefore, this is a vector quantity. So, magnetic field produced from a vector source, but electric field is produced from a scalar source, that is electric charge. Very important point. And the second point is directed along the position vector joining the source and the point at which the field is calculated. That means what? It is directed. If it may be the positive charge, the electric field should move like this only. Electric field here 100%. When we move, the electric field is decreased step by step. That only is given directed along this what? Position vector. This is the position vector R. Electric field is what? Here electric field. Position vector joining the source at the point at which the field is calculated. In this point only we have to calculate it, right, at P. But it is directed perpendicular to the position vector. In similarities I told, this is the conductor and position vector here. Here only we have to find out this magnetic field, the length dl, position vector r. The magnetic field in this point is what? Perpendicular to both the ideal as well as what? Position vector. Here perpendicular, right? Current element ideal, position vector r and current element does not depend on the angle. Very important here, because in this formula there is no sin cos. That is what? F is equal to 1 by 4 pi epsilon naught q1 q2 by r squared only. But here what? Ideal sin theta. Here depends on what? Angle. That angle is what? Angle between this position vector r and the current element dl. Depends on this angle only. Depends on the angle. That only is given. That is also one of the very important, because in Biot-Savart law dB is equal to mu naught by 4 pi ideal sin theta by r square. Trigonometric function sin theta is there, but here there is no sin cos function. Therefore, Coulomb's law, that means electric field does not depends on the angle, but Biot-Savart law depends on what? Angle between this ideal vector and r cap. This is the difference between what? Magnetic field as well as electric field, right? Now, very important 5 more question. Application of Biot-Savart law. The first application of Biot-Savart law, magnetic field due to long straight conductor carrying current. Magnetic field due to long straight conductor carrying current is very important. First application of Biot-Savart law. 5 more question. For that case, we have to consider a infinite length of conductor XY, infinite length of the conductor. Within the conductor, current I which are passing through it. So, due to current I which are passing through the conductor XY, we have to find out this magnetic field in this point to P at a distance A from center of the conductor at O. We have to find magnetic field in this point to P due to the current I which are passing through the conductor, due to current I which are passing through the conductor at a point to P from the center O at a distance A, at a distance A. So, for that case, we may use Biot-Savart law. When we want to use the Biot-Savart law, we may use what? A small element of length we have to choose. A small element AB of length is what? DL we have to choose. So, due to current I which are passing through the current element, that is within the length DL, the magnetic field in this point to P from the point at a distance R, magnetic field in this point to P, according to Biot-Savart law, magnetic field in this point to P due to current I which are passing through the small element of length DL, current I which are passing through the small element of length DL, according to Biot-Savart law, dB vector is equal to mu naught by 4 pi ideal sin theta by r squared into n cap. The n cap is the unit vector which have the magnitude 1. The cap will indicate the direction of the magnetic field. We discussed the direction should be perpendicular to ideal vector and r cap, position vector, right? So according to Biot-Savart law, dB vector is equal to mu naught by 4 pi ideal sin theta by r squared into n cap. We keep it equation number 1 in this point to P due to the current, that is current I, which are passing through the small element dl. Right. So in this case here, from this point here, the distance r, the angle between measure of angle APC is equal to d5, as well as BPA also measure of angle BPA also what, d5. At the angle, the measure of angle is what, OPA is equal to 5. OPA is equal to 5, and the measure of angle APC is equal to d5. APC is equal to d5. Right. From the point A, we draw a perpendicular line. We draw a perpendicular line to what? BP. To line BP. For this line BP, when you draw a normal line from the point A, that line which are meet the point C. If the line is perpendicular, that is a normal line, means the angle is what? 90 degree, even this is also 90 degree. Therefore, in this triangle ABC, opposite to 90 degree is called what? Hypotenuse. And in this triangle APC, opposite to 90 degree is called what? Hypotenuse. So if maybe it may be the normal line, mean this angle 90 degree, this is 90 degree. Therefore, this is a right angle and this is also right angle triangle. And here angle is what? 5. And here this is what? In positive side, negative side, here we have to take phi 1 is the angle, and this side is what? Phi 2 is the angle. So in this diagram, that is from the diagram, in right angle triangle ABC, here theta, sin theta is equal to, in right angle triangle ABC, sin theta is equal to opposite side by hypotenuse. Hypotenuse mean opposite to 90 degree. This is called the hypotenuse. This is theta, opposite side. So sin theta is equal to opposite side AC divided by what? AB. But in your textbook, the diagram is given in this case B, and in this point A is there. That is wrong. According to your textbook, that is equation is given. In that equation, according to equation, A should come here, B should come here. But in textbook, B is here and A is there. So very important, you must change. A is replaced by what? B. So sin theta is equal to opposite side AC, hypotenuse AB. The hypotenuse AB is equal to what? A small element of length dl. So cross product AB into sin theta is equal to AC. AB is equal to what? dl. So substitute instead of AB dl, dl into sin theta is equal to what? AC. We keep it equation number 2. Another triangle ACP. Even in this case, this is right angle, opposite right angle is hypotenuse. In this triangle, sin d5 we have to find, sin d5, this angle d5. Sin theta is equal to opposite side by hypotenuse, 90 degree opposite hypotenuse. So opposite side is what? AC. Hypotenuse what? AP. Cross product AP into sin d5 is equal to AC. So AP is equal to what? AP is equal to the distance R into sin d5 is equal to AC. And we know that if theta is small, then sin theta is equal to theta. If theta is equal to small, cos theta is equal to 1, tan theta is equal to theta, because tan theta proportional to sin theta. So if theta is small, mean then we may use sin theta is equal to theta. Therefore in this equation, sin d5 is there. So instead of theta value, d theta value is very small, because we may choose what? A small element of length dl. So the angle is a small angle d5. Therefore sin d5 we have to change is what? d5 only. Therefore the equation 3 we can write r into, instead of sin d5 we may use only d5, because the angle is small. This is equal to what? AC. So this is equation number 4. So r into d5 is equal to AC. Now equation 4 and equation 2, both of them you have to compare, because in right hand side in both the equation AC is there. So left hand side, therefore AC is right hand side, same in left hand side is what? R into d5 is equal to dl into sin theta. So r into d5 is equal to dl into sin theta we can get when comparing equation 2 and 4. We may keep it, this is equation number 5. Substitute the equation 5 in equation 1 instead of dl sin theta, So, substitute equation 5 in equation 1, dB vector is equal to mu naught by 4 pi I. Instead of dl sin theta, we may use r into d phi. R into d phi divided by r squared into n cap. R squared and r getting cancelled. The remaining is what? dB vector is equal to mu naught by 4 pi I into d phi, because r cancel, n cap divided by r, equation number 6. Equation number 6. And here we have to substitute r value. For that case, we have to consider another one triangle is what? OAP, right angle triangle. This is what? Right angle. So, opposite right angle is what? Hypotenuse. So, in triangle OAP or OPA, cos theta, cos phi is equal to what? Adjacent side by hypotenuse. Here phi, this is opposite side, this is hypotenuse, because opposite to right angle. Cos theta is equal to adjacent side OP divided by AP. Cos phi is equal to OP divided by AP, adjacent side by hypotenuse. So, cos phi is equal to OP is equal to A. From the center, the point P is equal to what? A. And AP is equal to what? R. AP is equal to R. So, R is equal to, when we need R is equal to A divided by cos phi. A divided by cos phi, equation number 7. Now, we know what? 7th, that is equation 7 is R value. So, substitute equation 7 in equation 6. So, substitute equation 7 in equation 6 instead of R, dB vector is equal to mu naught by 4 pi I into d phi divided by R value is equal to A divided by cos phi into n cap. Reciprocal with multiplication, mu naught by 4 pi I into d phi instead of R, instead of this, that is A by cos phi, we can write cos phi A, reciprocal with multiplication, into n cap. A by cos phi is converted into cos phi by A. Then mu naught I divided by 4 pi A into cos phi into d phi into n cap. Rearrange this equation, rearrange it. So, this is the magnetic induction at P due to the current I which are passing through the small element of length dl in this point, this value only. When you want to find out the total magnetic field in this point P due to the overall length of the conductor, B vector is equal to, we must integrate this what? dB. So, B vector is equal to integral dB vector is very important. Overall length means we must use what? Limit. The limit is what? Minus phi 1 2 plus phi 2, because in x and y axis this is what? Here negative and here what? Positive in y axis. So, this angle is minus phi 1, this is plus phi 2. So, the limit is between what? Minus phi 1 2 plus phi 2. So, B vector is equal to integral minus phi 1 to plus phi 2, the dB value is what? Mu naught I by 4 pi A cos phi into d phi into n cap. So, B vector is equal to mu naught I 4 pi A is the constant, mu naught constant 4 pi into 10 to the power minus 7, I constant 4 pi A constant, taken out the constant outside, the remaining factor minus phi 1 to phi 2 cos phi d phi into n cap. So, mu naught I by 4 pi A integral cos phi is equal to sin phi, integral sin theta minus cos theta. So, integral cos phi is equal to sin phi, the limit is minus phi 1 to phi 2 n cap. So, mu naught I by 4 pi A, substitute the limit sin instead of phi upper limit phi 2 minus sin instead of pi lower limit minus phi 1, sin of minus theta is equal to minus sin theta, you know that sin of minus theta is equal to minus theta, sin of minus theta is equal to sin theta minus sin theta. Therefore, B vector is equal to mu naught I by 4 pi A sin phi 2 minus sin phi 1 into n cap, then mu naught I divided by 4 pi A sin phi 2 minus into minus plus sin phi 1 into n cap up to here what? B vector. So, B vector is equal to mu naught I by 4 pi A sin phi 2 plus sin phi 1 into n cap. For entrance point of view, by using this equation, some questions may be asked. What are the question? I will explain afterwards. And in this case, if the conductor is what? Infinite in length, If the conductor is infinite length means what? Here the angle is what? Something. Here infinite length means what? From here the angle it will be vary. So infinite length means the line, that means the angle should start from here what? 90 degree. Therefore, for infinite length of the conductor, what happen means the theta phi 1 is equal to phi 2 is equal to 90 degree. So phi 1 is equal to phi 2 is equal to 90 degree mean B vector is equal to mu naught I divided by 4 pi a sin, instead of phi 2 90 degree and plus, and this one is what? Sin another one 90 degree into n cap. So mu naught I divided by 4 pi a sin 90 value 1 plus another sin 90 value 1 plus 1 is equal to what? 2. 1 plus 1 2. Sin 90 value 1 another sin 90 value 1 plus 1 is equal to 2. We can write 2 and 4 getting cancelled. 2 2s are 4 here 2. So the remaining value B vector is equal to mu naught I divided by 2 pi a into n cap. This is the magnetic field due to the current I which are passing through overall the infinite length of the conductor is what? dl. Suppose if the conductor is placed in air medium means we can get mu naught. Suppose if they ask the magnetic field at any point P at a distance a from a straight infinite conductor in medium means instead of mu naught we may use what? Mu. So this is the equation for magnetic field in this point P due to current I which are passing through the overall conductor of infinite length in medium, right? Suppose if they asked what are the questions which are coming from this heading in entrance point of view. In entrance point of view mean by using this diagram may be asked 3 type of questions. For entrance point of view, how the question maybe will come from this one, whether NEET, engineering, any engineering entrance examination. See, diagram is given. I told this equation, it's very important. Mu naught I by 4 pi a sin phi plus sin phi into n cap, or sin phi 1 plus sin phi 2, whatever may be, phi 1. That is the general equation. B vector is equal to mu naught I divided by 4 pi a sin phi 1 plus sin phi 2 into n cap. Actually, this is the formula. By using this formula only we have to derive. How means? Suppose if the length of the conductor is what? Finite, not infinite. If the conductor is what? Finite length. So finite length means the angle is not 90 degree. The angle is what? Both the end is what? Phi. So instead of phi 1, phi 2 we may use what? The angle only phi. Infinite length means something length. The distance as usual what here? The distance is what? A. The distance as usual the considered point A. So B vector is equal to mu naught I by 4 pi a. Instead of phi 1, phi 2 we may substitute what? Phi phi. So sin phi plus sin phi is equal to 2 sin phi. These two are getting cancelled. Even here also we can write this is equal to mu naught I divided by 2 pi a into sin phi d phi. This is the option may be asked. It is very important entrance point of view. And the second case, suppose this is the conductor as usual, the finite length. What is the magnetic field at any one of the extreme end, either x or y? So for that case, one angle will come to what? 90 degree, because right angle. Another one angle here 0. So phi 2 y1 is equal to 90 degree, phi 2 is equal to 0, or phi 2 is equal to 90 degree, phi 1 is equal to 0. So substitute here, one is 90, another one is 0, means sin 91, sin 0, 0. So mu naught I by 4 pi a into 1, this is 0. So 4 pi a into n cap only we can get. Very important point, even this is also very important. And third one as usual, if the conductor is infinite length, as usual the angle theta phi 1 is equal to phi 2 is equal to what? 90 degree. Phi 1 is equal to phi 2 is equal to 90 degree. 90 degree means sin 91, 1 plus 1 is equal to 2, just like we derived. So 90 plus 90 is equal to 1 plus 1, 2, 2 and 4 getting cancelled. B vector is equal to mu naught I by 2 pi a into n cap. This is very important. If entrance question which are coming from this topic, this is the idea. So no other way to entrance question which are coming from this topic. Okay, thank you.